right, everybody, get ready because today we are going deep into the world of binary.
Binary code.
That's right. It's the language of computers. And we had tons of requests from you guys to do a deep dive on this topic.
Yeah, for sure.
So
It's a good one.
get ready to unlock the secrets of the ones and zeros.
Yeah, because I think a lot of people hear binary and they think, ooh, that sounds complicated.
It sounds intimidating.
Yeah, but you know what? It's built on an incredibly simple concept.
Okay, I love it when complex things are actually simple underneath.
Exactly.
All right, so break it down for us.
Well, think about a light switch.
Okay,
The simplest on or off that there is.
makes sense.
Right. That's binary in its purest form. One is on, zero is off.
Okay, so
And computers use electricity, which is either flowing or not, so it's a perfect fit.
that's why computers use binary.
Yeah,
It's the simplest way to represent the on or off flow of electricity.
exactly.
Got it.
So it's more than a language, though. It's a number system.
Okay.
Just like our decimal system, 0 through 9.
Right, the one we use every day.
So we're all familiar with exactly. Binary uses just 0 and 1.
Okay, so there's only two options in binary 0, 1.
Exactly, 2 digits instead of 10.
Interesting.
But instead of powers of 10 like we're used to in decimal, like ones, tens, hundred thousands,
Right.
binary uses powers of 2.
Oh, powers of 2. I vaguely remember that from like high school math class or something.
Exactly.
But how does that actually like work to make numbers?
So think of it this way.
Okay.
You have a ones place,
Okay.
a twos place, a fours place, an eights place, and so on.
So it's not a tens place, it's a twos place, and it's not a hundreds place, it's a fours place.
Precisely.
Interesting.
Each position is double the previous one.
Okay.
Let's say you have the binary number 1, 0, 1.
1, 0, 1.
The one on the right is in the ones place.
Right.
Then a 0, and the next one is in the fours place.
Okay.
So you add those up and you get 5.
Oh, so 1, 0, 1 in binary equals 5 in our normal decimal system.
Exactly.
That's kind of cool. So every file image, everything on my computer, it's all just ones and zeros in different places.
Precisely.
Cool.
And here's what's even cooler.
Okay.
Every time you add another bit, you double the amount of information you can represent.
A bit being a binary digit.
Exactly.
Okay.
1 bit, 2 values, 2 bits, 4 values, 3 bits, 8, and so on.
Oh, wow. So it grows exponentially.
It explodes exponentially, and that's why computers have become so powerful so quickly.
Right, because every time you add a bit, it's like you're doubling their power or something.
It's that exponential growth that's allowed technology to advance at such a mind-boggling pace.
That makes sense.
But what's truly fascinating is how this simple system represents not just numbers, but everything digital.
Okay, wait, now I'm confused. How do you go from ones and zeros to cat videos and online shopping?
Well, everything we see and interact with digitally at its core is just data. And that data, no matter how complex it seems, can be broken down into ones and zeros.
I mean, I get it, but my brain is like doing backflips trying to picture that.
Yeah, it's a lot to take in.
It is, but I'm hooked. Tell me more.
All right, so let's start with something simple like text messages.
Okay.
When you type a message, each letter and even each emoji is converted into binary code.
Hold on. So there's a specific binary code for each letter.
There is. It's called ASCII, and that's how computers understand what we're trying to say.
Okay, so when I text my friend LOL, my phone is actually sending a bunch of ones and zeros.
Exactly.
Wow. Pretty cool, right?
It is. So what about like music? How does that work with binary?
Well, music is just sound waves, and sound waves are analog, which means they're continuous.
Okay.
But to digitize them, we take snapshots of the sound wave at regular intervals, and those snapshots are assigned a binary value.
So it's like turning a smooth curve into a bunch of tiny steps.
You got it.
And each step has a binary code.
Exactly. And that's how your device recreates the music by reading those binary values.
So those catchy tunes I'm humming are basically just numbers.
Yes.
My mind is blown. And video works in a similar way. Each frame is a still image, which can be represented by binary values for each pixel's color.
So a video is like a flip book of binary encoded images.
You got it.
Wow. I never realized how much data goes into watching a YouTube video.
It's a hidden world operating beneath the surface.
And it's all thanks to the power of binary.
But understanding binary isn't just about appreciating the technical wizardry.
Right.
It's about understanding the foundation of our increasingly digital lives.
I'm starting to see that knowing that everything digital is built on this simple system of ones and zeros makes you think about the online world in a whole new way.
Exactly. And that understanding can be surprisingly empowering.
Yeah, you're right. It's like it demystifies the technology.
Exactly.
So where does binary go from here? Is there a limit to what it can do?
That's a great question.
Because it seems like we've come a long way with binary.
We have, but there are exciting new developments on the horizon.
Oh, like what?
Fields like artificial intelligence and quantum computing are pushing the boundaries of what's possible with binary.
Okay, now you've really piqued my interest. We have to dive into that.
We will.
AI quantum computing. It sounds like we're on the verge of a whole new era of digital innovation.
We are, and while these are complex topics that deserve their own deep dives, understanding the role of binary in these advancements is essential.
Well, I'm on the edge of my seat.
Then buckle up, because next, we're venturing into the realms of artificial intelligence and quantum computing.
Ooh, I can't wait. Let's go.
Get ready for a glimpse into the future of binary.
Okay, so we're talking about how everything digital boils down to binary.
Yeah.
But, like, how does that actually work in the real world? Like, when I text my friend, like, a funny meme, is it really just ones and zeros?
That's exactly it.
Right.
Every letter, every emoji, every punctuation mark,
Wow.
it all has its own unique binary code.
So there's like a code book for this.
There is. It's called ASCII. Yeah, it stands for American Standard Code for Information Interchange.
Oh, wow.
So when you type the letter A,
Yeah.
your phone converts it to the binary code 01000001.
01000001.
Yeah, and then that gets sent to your friend's phone.
And their phone knows how to decode that but back into the letter A.
Exactly. It's like a secret language.
That's wild.
Yeah.
Okay, so what about things that aren't text? Like, how does binary work with music?
Music.
Yeah.
Well, music is just data, too. When you listen to a digital song, what you're actually hearing is a representation of sound waves,
Okay.
but those sound waves have been converted into binary.
Hold on. So you're saying my favorite songs are just numbers?
In essence, yes.
How does that even work?
So sound waves are analog,
Okay.
meaning they're continuous like a smooth curve.
Right.
But to digitize them, we take tiny snapshots of the sound wave at regular intervals,
Oh, interesting.
and each snapshot captures the intensity of the sound at that moment.
So, like, how loud or quiet it is.
Exactly. And then each of those snapshots is assigned a binary value.
So it's like taking a smooth curve and turning it into a bunch of tiny steps.
You got it.
And each step is a 1 or a 0.
Precisely. And your device reads those binary values and converts them back into electrical signals
To make the sound.
to drive your speakers. Yeah.
So it recreates the music.
Exactly.
That is incredible. It's like taking something organic and fluid like music and turning it into this perfectly precise sequence of ones and zeros.
It really is. And it's the same principle with video.
Oh, really?
Yeah. Each frame of a video is essentially a still image,
Okay.
which we know can be represented by binary values.
For each pixel's color.
Exactly.
So a video is like a flip book of binary encoded images.
You got it.
Wow.
And the smoother the video, the more frames per second are being transmitted, which means more data.
More ones and zeros flying around.
A whole lot of binary data. Yeah.
This is blowing my mind. I never realized how much data goes into something as simple as watching a YouTube video.
It's a hidden world operating beneath the surface.
It really is. And it's all thanks to the power and flexibility of this simple system.
Yeah, and understanding binary.
Yeah.
It isn't just about appreciating the technical wizardry, it's about understanding the foundation of our digital lives.
It totally is. I mean, knowing that everything digital is built on this simple system of ones and zeros, it really does make you look at the online world in a whole new way.
And that understanding can be really empowering.
Yeah, you're right, because it kind of demystifies the technology.
Exactly.
Where does binary go from here? Is there a limit to what it can do?
That's a great question. We've come a long way with binary.
Yeah.
But there are some really exciting new developments on the horizon.
Like what?
Fields like artificial intelligence and quantum computing are pushing the boundaries of what's possible with binary.
Okay, now you've really got me interested. We've got to dive into that.
We will.
AI, quantum computing. I mean, it sounds like we're on the verge of a whole new era of digital innovation.
Yeah, we are. And while these are complex topics that deserve their own deep dives,
For sure.
understanding the role of binary in these advancements is essential.
Oh, I'm on the edge of my seat here.
Then buckle up, because next we're venturing into the realms of artificial intelligence and quantum computing.
Ooh, I can't wait.
Get ready for a glimpse into the future of binary.
Okay, so we've gone deep into the world of ones and zeros.
We have.
Seen how they shape everything from text messages to videos.
Yeah.
And even got a glimpse of quantum computing,
Right?
where bits can be both 0 and 1 at the same time.
Yeah. That's mind-bending stuff.
It really is.
Hmm.
So where does binary take us from here?
That's a great question.
What's next for these ones and zeros?
Well, I think As binary continues to underpin these advancements in AI and quantum computing,
Right.
it's pushing us to think about its impact in a whole new way.
You mean like ethically?
Yeah, exactly. I mean, the code itself
Right.
isn't good or bad. It's how we use it.
It's like a hammer.
Oh, that's a great analogy.
You can build a house or you can break a window.
Right,
The
exactly.
tool itself is neutral.
Yeah, so it's not about fearing the ones and zeros themselves.
Okay.
It's about making sure we're using this powerful tool responsibly.
Because it is powerful.
It is, and as it becomes even more intertwined with our lives,
Right.
we really have to think critically about the implications.
Like what kind of implications?
Well, for example, as AI algorithms get more sophisticated,
Uh-huh.
they're being used to make decisions that have real-world consequences.
Right. Like what?
Loan approvals, medical diagnoses, things like that.
And those algorithms are running on binary,
They are.
processing tons of data.
Right, and that data can reflect existing biases in society.
Oh, that's interesting.
So if we're not careful,
Yeah.
those biases can get baked into the algorithm.
Leading to unfair outcomes.
Exactly. So even though it's just math and code,
Yeah.
binary can inadvertently perpetuate real-world inequalities if we're not paying attention.
So we really have to be mindful of the bigger picture.
Absolutely. The more we understand about binary and its capabilities, the better equipped we are to shape its development in a way that benefits everyone.
This has been such an eye-opening journey.
It has been.
I mean, we started with something as simple as ones and zeros.
Yeah.
And now we're talking about shaping the future of technology and society.
It's amazing, isn't it? Binary might be the language of computers,
Yeah.
but it sparked a conversation about human values, ethics, and responsibility.
A conversation we all need to be a part of.
Absolutely.
So as we wrap up this deep dive into binary,
Yeah.
I'm left with a sense of wonder, but also a renewed sense of purpose.
I feel the same way. Understanding binary
Yeah.
is like gaining a superpower.
It kind of
It's
is.
the ability to see the code beneath the surface
Right.
and participate in shaping the digital world around us.
And that's a power we should all wield thoughtfully and responsibly.
Absolutely. So the next time you send a text,
Right.
stream a video, or interact with AI, remember those ones and zeros working tirelessly behind the scenes?
Okay.
They're more than just code. They're a reflection of who we are and the future we're creating.
Well said.
Thank you.
A huge thank you to you for guiding us through this incredible deep dive into the world of binary.
It was my pleasure.
And to everyone listening, keep those questions coming.
Yes, please do.
The exploration of binary is just beginning.
It is.
Until next time, stay curious and keep exploring.